Hello, everybody, and welcome to this episode of the Future Space Economy webcast, brought to you by Via Satellite Magazine. This episode is supported by our friends at Kepler, Northrop Grumman, and Rocket Lab. So we thank them for their support in bringing this educational conversation to our industry and beyond. As I said, this episode is called Evolving Launch and Delivery Infrastructure to Support an Expanding Space Economy. So, we talk a lot about launching to LEO, launching satellites via satellite. We cover the satellite industry. This discussion, however, we're going to focus on supporting launch and orbital delivery service demands for the future space economy beyond just satellites to LEO. We'll include that a little bit, but we're going to talk about sending people to the moon space station, sending satellites beyond GEO to the moon and beyond, sending scientific missions beyond GEO. And sending in-orbit support infrastructure like refueling, servicing to space. We're going to even talk about what do we have to build in space and what do we have to build on Earth in terms of our launch infrastructure, and also making all of this sustainable and safe for everybody operating in orbit. I am also joined today by our senior managing editor, Rachel Jewett at Via Satellite, who will lead our discussion. And I will also help her with the audience Q&A. I'm going to introduce our three fantastic speakers in just a moment. But before I do, I want to remind everybody in the audience that at any time you can submit questions to us using the Q&A tab on the right-hand side of the screen. We're not going to wait until the last minute for audience questions. We like to weave them in as you ask them if they are relevant to our discussion. I won't say who you are. You can submit the questions and I'll facilitate that question for you. So please don't be afraid to ask questions. It really does help us fine tune this discussion so it's helpful for you. So without further ado, I'm going to introduce our speakers and then hand it over to Rachel. Our first speaker is Jeff Brink. He's a flight systems engineer of deep space logistics for NASA's John F. Kennedy Space Center. Jeff, it's great to have you here. Thank you so much for joining us. Could you just tell us a little bit, what's the big project on your plate right now? What are you working on?
Yeah, the big project for me personally right now is the Lunar Terrain Vehicle, which is a lunar rover as a commercial system. So NASA's pretty heavily invested at this point in our architecture and trying to have industry support our moon to Mars architecture. And the LTV system is 3 different providers, kind of all in competition right now, trying to bring concepts all the way through a PDR design level to provide us that capability eventually. Excellent.
Well, thank you, Jeff. Next up, we have Kurt Eberly. He's Director of Space Launch at Northrop Grumman Space Systems, which is maker of the very popular James Webb Space Telescope, the rocket booster and various systems for NASA Artemis, Mission Extension Vehicle, MEV, which we talk a lot about here, which is servicing satellites. So, Kurt, it's great to have you here. Thanks for being with us. Northrop Grumman works on almost every level of technology in space. Can you tell us a little bit about what's on your plate right now? What's your next big project?
Sure. Thanks, Jeff. Super excited to be here. I manage space launch programs within our launch vehicles business unit. And so that includes Pegasus, Minotaur, and Antares. And for Antares, we are in the midst of an upgrade in collaboration with Firefly Aerospace to develop first the Antares 330, which is just a replacement of the first stage, as if that wasn't complicated enough. And then replacing the second stage to create what we are calling cleverly the medium launch vehicle. I promise we're going to have a really great name soon that we will put out. But we're in the midst of that development and hoping to get back launching ASAP from Virginia, from our Wallops launch site. We also have a number of Minotaur missions on the books, and that's really for a Space Force rocket where we repurpose excess strategic assets that have been decommissioned and turn them into space launch or suborbital test vehicles for the Space Force for a number of their ultimate customers. So just to, we're part of this launch vehicles business unit. We also do a number of targets and other projects that other folks are managing, but we draw on a common set of avionics, software, engineering processes, and so on. That allows us to really have a lot of high flight heritage on everything we do across the fleet of vehicles we fly. So we may fly, we may do 20 or 30 launches in a year. You don't hear about most of them because they're, a lot of them are targets and military purpose. But again, drawing on that same common resource pool really gives us a lot of experience and heritage from years back that we can apply to these new projects.
Excellent. Well,
Thanks,
it's great
Jeff.
to have you here, Kurt. And then we also have with us Brian Rogers. He's Vice President of Global Launch Services at Rocket Lab, an end-to-end space services company. And what that means is they do everything. So, right, they're the makers of the Electron dedicated small sat launch vehicle, the HASTE suborbital test bed launch vehicle, the Photon spacecraft, and the upcoming medium lift vehicle, Neutron, as well as all the hardware and software expected from an end-to-end company. Brian, thank you so much for joining us. I know we had Peter scheduled originally, but he had a conflict of schedule. So thank you for jumping in here last minute. What is on your plate? What's the next big project on your plate?
Yeah, thanks for having me. Peter Beck, big shoes to fill. So I hope I can meet that intent for you today. I do lead a team called Global Launch Services. I think you nailed it. While we have the two business units, the idea is totally vertically integration. We have 42 satellites in backlog with Photon, and there's a variety of products within there. Includes interplanetary, includes LEO, defense, civil, and then we have our launch business unit. And you nailed it. Electron's launching 20 times this year. If all the spacecraft show up on time, that is. We have the HASTE suborbital platform that is doing great work, and you'll see a couple more of those launches this year. The nation has a need for high cadence hypersonic test flight, and our HASTE platform delivers that very well. Neutron coming to market next year, looking at about a July flight there. So a lot of good things happening at Rocket Lab.
Excellent. Glad to have you guys here. I'll now turn it over to, as I said, Via Satellite Senior Managing Editor Rachel Jewett. She's been with us 5 years. She's already the smartest space journalist I know. And I know she's got a lot of things to talk about here. So Rachel, I'll turn it over to you, and I'll keep my eye on the audience Q&A.
Awesome. Thanks, Jeff. I'm excited for a great conversation today. Jeff Brink with NASA, I'd like to start with you. So the last time NASA went to the moon was the Apollo 17 mission in 1972. And now the agency is investing in the Artemis campaign to return humans to the moon. So can you explain to the audience, how is Artemis different from the previous endeavors?
It's very different. It's, kind of first by intent. If we go back and look at the space race, that was really about national posture, national prestige. Whereas now the Artemis program is focused on science. It's focused on having a continued human presence, beyond Earth. So those are a couple really important differences of why you go. It'll also look different. So we're going to have the first woman on the moon. My daughter is going to get to see that, which is fantastic. First person of color as well. We've got international astronauts. JAXA is going to have a Japanese astronaut on the moon at some point here. We've got a Canadian astronaut that'll be a part of the Artemis 3 mission. So really just kind of a short time away there. So it'll look different as well. As far as, how is it different? It is actually pretty different in implementation. We have what we call a Moon to Mars architecture, and it's really a framework. So the way that it works is that, we identify what our needs are, and this is all publicly available, but we identify what our needs are. So if, for example, you wanted to have astronauts at the south pole of the moon, you would have a need that says, we need to be able to generate power, and we also need to be able to communicate back with Earth. And so those would be a couple needs that you define. And then what you're trying to do is be able to say, all right, do we need to develop technologies for that? Are there opportunities for industry there? Where we could potentially have some competition, some of that commercial innovation that we like to foster. So it ends up being kind of built on industry, and it's a kind of a clear plan of how we're trying to get there.
Awesome.
Thank you, Rachel.
All right, I'm going to kick it over to Brian now with Rocket Lab. And also, Kurt, feel free to, you guys, if the question isn't addressed to you, feel free to pop in if you want to weigh in. Kurt, considering how much launch activity we're seeing just to launch satellites and people to low Earth orbit, how do you anticipate the demand for launch services evolving in the coming years, especially with global plans for lunar missions?
Well, I think, Brian, do you want to go first? I think she was targeting me.
I apologize. Yes, that was meant for Brian.
I'm sure we're both very interested in talking about launch, so I appreciate it, Kurt. Yeah, I see demand increasing. I think there is a total bottleneck that we are seeing. There's one primary provider, and the market is demanding more. That is for LEO constellations and higher energy orbits. So we've seen this tremendous interest in the moon and science, as Jeff described. So I don't see the demand signal going anywhere. There's a lot of new exciting launch vehicles coming to market to fill that need. It'll be interesting to see what that does. That has been a very long development tail. All right, we've seen many of these vehicles in development for a long time. So I think it's a little early to say what that's going to do. And then if we're all headed for the space economy that we all hope is coming, I think you're going to start seeing space launch take the form of more like an airport, right? You're going to have the huge vehicles that are servicing that part of the market. You have a need for medium, doing a lot more of the ferry, and then you need small and dedicated for these very precise orbital insertions. And it's exactly what you see in the construct of a commercial airport today. So that is to say, I see demand increasing continually. We're very excited about that. That's part of our vertical integration strategy, but we also continue to be a merchant supplier. We're going to launch, all of the space economy going forward.
Can you explain what you mean by high energy orbit? I just want to get clarification on that term.
I just mean outside of LEO. So MEO being higher energy, a GTO or a GEO, and then certainly an escape orbit. So I think those are all related also to this idea that we need to have more time on orbit. So LEO is an interesting thing and where you can go back and forth quickly, but particularly on the national security side, we've seen an interest for the capable for a second stage or a space tug to be able to get into cislunar space and to have the capability to remain there for a while, which enables your mission life. So that's what I mean by high energy. It's not just the C3 to get out there, but also the technology platform that can keep science or transportation experiments alive.
Mm-hmm. Yeah, thanks for explaining that. And Kurt, what's your outlook on launch demand in the coming years, and not just for satellites, but for everything that's going to enable the future space economy?
Yeah, I agree with Brian. It's going that way. Certainly up over the next 5 to 10 years. We see a lot of demand for LEO constellation deployments. I think that's probably the most that we see. Highest number of launches are going to be for deploying these constellations. I think, there will be some out to MEO, GTO, and GEO, and then a fewer number for Earth Escape and lunar. That's just not that commercial demand signal for those higher energy orbits yet. But yeah, we're super excited to get in there with the medium class. We think kind of a 5 meter fairing, medium class to lift to orbit is kind of the right size for these kind of deployments, the right economies of scale for these constellation deployments. And then we also intend to address national security launch. We just saw the announcement the other day from the Space Force where they awarded 9 launches, I think it was, to SpaceX on Lane 1. Now they're a Lane 2 provider, but obviously none of us have shown our ability to launch on Lane 1 yet. So that's something we're super excited to get on-ramped and start doing. And obviously there's a need there. And I think, the Space Force wants, they want more competition. As Brian said, there's a monolithic environment right now, and they want us to come in and be competing and driving those prices down. And also, aside from just the competition is good for cost and lowering prices, they also want just the risk reduction and the resiliency of having multiple launchers from multiple ranges. And so, our position from Wallops and Brian's Neutron is going to go out of there too. That's a great alternate to Cape Canaveral, and we see Assured Access to Space organization is super interested in in having Wallops available to them on the NSSL contract. In fact, Brigadier General Panzenhagen was up touring in June around Wallops just to take stock of what was there and what's to come. So yeah, a lot of interest, and that's what we see for the next 5 to 10 years.
Just want to jump in here too about the going off the demand. What about the demand for like new propulsion systems, delivery systems, in orbit service, anything like? What does the demand look like for the supporting infrastructure? Because we'll talk a little bit about infrastructure that we mentioned like on Earth in just a bit. But I just want to say, like, what about the space systems on the space system side, Kurt?
Well, I actually think, we're collaborating with Firefly Aerospace. They are, very vertically integrated. They're designing and manufacturing a new rocket engine called Mirage for the first stage and Vera for the second stage. And I actually think, the innovation here is producibility, lower cost, high reliability, and reusability. I think it's a trend away from exotic propulsion. So if you're thinking, now's the time to bring in, nuclear propulsion from the ground up, and just something exotic, that's not where we're at. I think we're trying to field systems on a development timeline so that we can get in the market. We're trying to keep costs down, but reliability has to be high. That's certainly what the government customers want. The commercial companies expect it, and then it needs to be reusable. We're seeing that, and the first stage of our MLV will be reusable. We're going to start off expendable, and then we will cut in those features as we go along. But so I think, in response to your question, I don't see a drive towards some wholly new propulsion combustion cycle or something that hasn't been proven out, because I think there's a desire to just, hey, let's stick with what we can build quickly and at a good cost point and is super reliable.
Thanks. And Brian, you want to jump in with, and also, you can answer from the end-to-end perspective, like what's the demand for launch and end-to-end services like Rocket Lab provides?
I'd say, generally speaking, I agree with that assessment. So infrastructure starts on the ground. The launch diversity is not just providers, but it's infrastructure on the ground, including your site and your processing facilities and supply chain diversity. So it starts there. In terms of novel propulsion systems, I agree. Always need to have your eye on the horizon, looking for that next thing, whether that's nuclear propulsion methods or other things. But what we've seen is more of that producibility. Our customers are asking for dollars per kilogram to orbit and fielding their constellations in a timely manner. They're not asking us for some novel propulsion system. Now, those questions can be related, certainly, if the cost isn't there, right? But it's about more manufacturing and producibility. On the space segment side, particularly when we're talking about on-orbit maneuverability, it's how much delta V can you pack into a smaller system, or, like I said before, longer duration missions. So with our Photon spacecraft, we have not targeted a part of the market that is just the low-cost proliferated LEO necessarily. Now we can do that too, but you'll notice there's a high delta V, a hard GNC aspect to all of it. So we like those challenging problems. And that's the end-to-end solution. If you put that together, you need a reusable launch vehicle that is sort of a table stakes going forward. And then you need to have high delta V platforms that can do the on-orbit maneuverability and the missions that customers are asking for.
Thank you.
I want to follow up with another question about the investment on the ground. So what investments are being made in that infrastructure, like launch sites, in order to amp up the cadence of launch that much? You're going to need more infrastructure on the ground, support facilities to accommodate these future missions beyond LEO. So Kurt, I'll start with you on that one.
Okay. Yeah, I think Brian's analogy of an airport is a great one. If you say to an airline, hey, to start up your airline, you're going to have to build an airport too. But at both ends of wherever you're flying, you would say, geez, that's really impossible for me to stand up my business and close my business case. So, we've found, Wallops is a great example. We have a state-owned and operated spaceport, Virginia Spaceport Authority. They're part of the state Department of Transportation. They have come in. They've really grown since our first days of talking to them back in 2009. We decided to come to Virginia over Florida. No offense to Florida, we like Florida, but we just thought it was a better path forward and a better deal. And I mean that's what we see with all these companies, right? Is states are vying for that business, and they have an economic development organization in each state trying to offer incentives. Just like Amazon HQ2 came to Virginia because of various incentives that were offered. So I think that's great for our industry, is to be able to get that support from the state level organizations, because it's not just a matter of dollars and cents. I'll give you a great example. We were going to bring in our first stage of Antares into Wallops Island. Well, we were going over the road from Wilmington Port, and coming down the road, there were 96 low hanging wires between the main base and Wallops Island through the little town of Atlantic. So there, a private company, if you said, gee, how are we going to solve this problem? They went and just did it. They just did it. They had the authority to do it. They had the right of way, and they solved the problem and just, buried a bunch of the wires and raised some others and took care of it for us. So they've been just a super essential partner. They own and operate the launch pad. We pay a fee to use it every time. That's a great paradigm for us, and allows us to focus on just the rocket part, which is plenty hard enough, and everything we got to do. So I see those continued investments from the state super helpful, and we're seeing a continued commitment from Virginia. They've been awesome. They're really standing up a world-class capability there, and it's not just launch pads. There's a payload processing facility that the VSA runs. That's going to be booked up quickly, I would think, and I know that they've got plans to expand and create some other facilities. So that's the kind of support we need. When we go out to Vandenberg for Minotaur, there is no similar state level organization out at Vandenberg. It's really Space Force looking out for themselves, and so there it's a different it's just a different paradigm, and you got to try to work there and get a parcel leased to you and then do your own construction. So there, it just makes it harder at Vandenberg, a little bit of a barrier to entry, I would say, compared to what our experience has been at Virginia.
I guess I'll take the second half of that question. I think Kurt did a really great job illustrating the market economy sort of aspects to it, but let's talk purely technical as well. At Cape Canaveral, there's a lot of launchers and there's a lot of companies. As we enter the era of reusability in a big way with multiple providers, you have multiple launches per day and landings. You have people doing integrated hot fires, that sort of thing. And all of these have a safety keep out zone. With the introduction of LOX methane as a very appealing set of propellants for reusability, there are keep out zones associated with each one of those. And if you look at the seashore at Cape Canaveral, a lot of those keep out zones overlap. So when we're talking about launch over availability over an area like that, it's not just the launch vehicle and having one on the pad and being ready to launch. It can also be vying for space with your competitors. We've seen bottlenecks in Cape Canaveral with payload processing facilities. And I know that there's private companies and everyone making investments there to open that up. But that's part of the benefit of having multiple launch sites. So Rocket Lab right now, we have 2 sites that service Electron out of New Zealand, out of Virginia, and that allows us to have our own private launch site and move quickly. We're not vying for other competitors there. And I think it's going to become even more important to have that launch site diversity as the Cape gets very busy and we have competing priorities on schedule.
All right, I want to jump in with an audience question here because this is interesting. As we're talking about investment in launch sites, someone wanted to know, in your experience, how do space launch sites interact with their local economies? So how does building a space hub impact the people that live there? And Jeff, I'll go to you because Florida is the case study here, right? Florida's economy, the space Florida and the space coast there, I mean, really is the economy there. I know you're a flight engineer, so but you being in Florida, how does having Cape Canaveral there and the Space Center there impact the local economy?
It's grown tremendously. I mean, they've got statistics. I don't know if it's 4-to-1 or 5-to-1. For every dollar invested in that spaceport, the local economy grows to that extent. it's also fun. I mean, yesterday, I was at swim practice with my kids, and you see a rocket launch, right? Like we're just about at the point where there's 2 a week. So if you come to Florida for a week, you're almost for sure going to see a rocket launch. But there's a lot of, and I guess maybe going back to something that Brian talked about it's not just about having a rocket on the pad and then being able to launch it and see it launch. There's a whole ecosystem of support around that. There are whole industries that go into, and suppliers and so forth, that go into being able to support that activity. And that even, includes extending into academia, right? And being able to have universities that you partner research with and that sort of thing. So it really affects, like you were saying, Jeff, everything in the area is able to grow and be healthier because of it.
Absolutely. Yeah. Kurt, Brian, you want to jump in? I mean, I know if you want to talk about, this is really the foundation of the space economy, right? This is one of those projects where there's immediate impact on the general public, right? And you're saying like this creates jobs and business opportunity. Any thoughts there?
Well, I'll just say, Eastern Shore of Virginia is a historically, depressed area. Since we started launching there with bigger rockets in 2013, we've seen incredible growth. We have a new hotel in Chincoteague. Chincoteague used to just be kind of a resort town that would get populated in the summers, but now it's really kind of year round, and we actually have some restaurants that are open in the winter too. So that's great. We see continued presence there all year round, and that's drawn in folks to come work in that area. Now, that's something we're really working on hard, with the Space Grant Consortium for Virginia and those folks. There's a new governor's lab school that's opening up, and the theme here is to try to bring in the kids and get them interested, really as early as grade school and then middle school. And so by the time they get to high school, they're ready to apply for something like this lab school that really kind of has the STEM education. And because the idea here is that we see folks who grew up in that area, they want to stay there for the long term. And so they're the folks that can really provide that steady workforce and really high capability workforce that we need, high-tech workforce in that area. So we've seen a lot of that. We've got a permanent presence there, and we've had some great folks been able to keep our core engaged there. But we do see, kind of fresh outs from some of the aerospace universities. They will come down, work for a couple of years, and then they think, this is sort of a small rural area. I'm going to go back, to a city or something like that. So we are trying to, kind of establish more of the local populace, getting them engaged in STEM and then hiring them onto our workforce.
Yeah, I agree. You don't see launch sites put in the middle of metropolitan areas, right? It doesn't work in the middle of a city. So there is a different aspect there when you talk about jobs creation and stimulating a local economy. And I agree with everything that's been said. We set up our own launch site on the Mahia Peninsula of New Zealand, but that meant that there was a lot of civil work that needed to happen. There's an entire supply chain that feeds that launch site. When we have launches, which are happening every 2 weeks or so, there's an influx. It stimulates people flying into the country. And then you could say the same thing is true of Cape Canaveral and Virginia as well. You have these entire supply chains. And as the companies continue to grow, you want to expand. So for our company, we started with an Electron pad. That went well, and it's launching, and now we're bringing Neutron to market. And so there's a gigantic pad and another water tower and a whole bunch of concrete work and payload processing facilities. There's even some bridge work that's required. And Kurt even talked about how the power lines had to be moved. So it stimulates just the economy in that way. And I don't know that leads to explosive population growth. That's not really the idea. But it does keep the people who want to be there with interesting things to work on, and some of the fresh outs, and everybody gets that hands-on hardware experience. That's really great too.
Thanks.
Yeah, really interesting. Jeff, I'm going to pose this question to you. Is having a robust in-orbit servicing and manufacturing part of the requirements to achieve NASA's future goals in space?
Yeah, it absolutely is. I talked earlier about the Moon to Mars architecture, and so there are capabilities that are laid out in there. If we just kind of talk about like what are those capabilities, like you talked about defining terms. So with on-orbit servicing, you're potentially performing repair of an asset or a capability that otherwise would be able to remain in service. So, and you're comparing that to having to launch a replacement for it. So, potentially you've got something that's good that just has one issue, and you're able to repair it and continue using the capability. And then also, you're potentially, if you're able to service it, say propellant transfer and that sort of thing, you're able to extend the life of that spacecraft. So, I don't know, maybe we reach a point where someday we have antique license plates on spacecraft or something like that. I don't know. So that's the on-orbit servicing part of it. From a manufacturing part, you're no longer constrained by the payload fairing. So I had we went to a conference and somebody had made a comment about anybody who's a Star Trek fan, you need on-orbit manufacturing to be able to build a starship, right? To be able to build Enterprise. So you're no longer limited by the payload fairing, and that's a pretty major benefit. It also keeps you from having to launch finished goods, right? You could potentially have materials that you're then able to go manufacture. The materials aspect, of course, brings into play the in situ resource utilization. So, what are the resources that are available to you that you could use to manufacture something? And so, like I said, that comes into play. You can potentially build spares, so you don't have to bring spares for absolutely everything. So you can see lots and lots of benefits to these capabilities. And if you want to kind of really stretch your mind and say something that's a little further out there, if you talk about reusing, resources that are available to you that are around, maybe at some point we reach a point where space junk, orbiting the Earth becomes, resources that could be able to be, manufactured into something else that's more useful. With all that said, I want to talk about, so these two capabilities sound exciting and promising, right? But as you start exploring the solar system, you've got to keep reliability in mind. So if you're expecting the capability to work, it's got to have enough reliability that you can really count on it, right? And that's especially important to us when we talk about crew, when we have humans out there exploring. And so I guess kind of going back, and just maybe one other thing is from a deep space logistics standpoint, we talk about creating a deep space supply chain. One way that we're doing that is, you talk about trying to eliminate waste. So we have a partnership with a company called Re3D. So if you think of packaging foam, and that packaging foam is essentially waste. So the partnership that we've got with them is exploring, can you take this packaging foam, can you break it down? Can you 3D print it into something that's useful, like a shop aid or a tool? And if you can't do it with this foam, are there other types of foam that you could potentially use, other types of packaging materials you could potentially use? So, that all kind of goes back into the idea of trying to, sustainably explore space.
That is super interesting about the foam. And I remember, Northrop Grumman Space Logistics, the demonstration with Intelsat being the first in orbit servicing was such a cool moment for the space industry a couple years ago. And now we're seeing more companies get closer to their own demonstration. So it's very, very exciting to see how these capabilities will evolve.
Yes, that was super cool. If you ever get a chance to see the video of docking with the Intelsat spacecraft out in GEO and the Earth in the background, that was super neat. We've provided more than 8 years of life extension to those satellites that have run out of fuel. I mean, these satellites are huge, expensive geosats that have custom antennae that are conform to the land that they're going to radiate to and so on, and they're working perfectly. Transponders are going. They just run out of fuel, and typically it's about a 15-year life on these spacecraft. And so we've stood up this ability with the mission extension to be able to kind of, it's like a jet pack you glom on the back, although it's not really jets, it's more electric propulsion that then flies and does the station keeping and does the maneuvering for those spacecraft, where they're perfectly fine spacecraft. They just run out of fuel and extending that. And then once we're done there, we'll move to another spacecraft. So we'll see where that heads. It's super exciting to start seeing that economy get built. I'll
take a slightly different angle to this. And by the way, I am a science fiction fan. So all of the in-space manufacturing, bolting rocket engines to asteroids and doing in-situ resource utilization. All of these things are just fantastic. I think there's going to be a little bit of a give and take there. And I would couch that as, what is your mission's distance from Earth? Because as we see the ability to put things into LEO very quickly and repeatably, refresh technology, the need to do things on orbit, I would say, diminishes because you have all of your supply chains on the ground. As you get further from the Earth, though, and there is both a time and energy lag in order to do these things, I see it being more important. And then certainly there's some very interesting things about if you're doing Earth observation or deep space observation, just the size of your optic comes down to a physics problem, right? You need to capture a certain amount of light. So you can either use a deployable optic and fit within an existing payload fairing, or you can use some kind of aggregate system up that does the in-space manufacturing, and then you get these huge optics. So there's a lot of technical challenges with that, but it's very exciting, and it's just two different ways of solving a problem. So it'll be interesting to see what we come up with in the future.
Yeah, that's a great point about what makes sense for each orbit and distance from Earth. So over the past decade, we've seen reusable or partly reusable launch systems become a reality, and we've seen how this has lowered costs and increased launch availability. What future design features or innovations should be or are being incorporated into launch vehicles right now or in the near future to optimize performance and efficiency for these beyond LEO missions? So are there specific challenges or breakthroughs that you guys are watching and anticipating in reusability? Brian, I'll start with you on that one.
Okay. Well, Neutron is our answer to this question. So I agree. From a market standpoint, if you haven't included reusability, it's just not going to work for you. That's table stakes. And then in terms of the technologies that enable that, certainly a propulsion cycle that lends itself to being reused is important. With our Archimedes engine that we're using for Neutron, you basically have to pick your miracle in the program. So if you have a very heavy set of tanks, you need an engine that's squeaking out every last second of ISP in order to lift that. Well, at Rocket Lab, we're very good at cryogenic composites. So we have linerless composite tanks that are the primary structure on Neutron. And what that means is that's the miracle of the program. And our Archimedes engine can run not looking for that last second of ISP. It can run cooler. And so the analogy that we use is if you're flying over the Pacific, you don't really want to look out on the wing of your airplane and seeing that engine glowing red hot, needing to be refurbed, have to be inspected after reuse. And so we're designing this launch vehicle to run more like a commercial airline model. Similarly, I wish I had a picture of it right now, but we have an overall engineering construct where the entire first stage comes back as one piece, and that includes the payload fairing. So the right way to think about that is more like a nose cone that opens up on a hinge. Stage 2 deploys from within, we close it, and we bring that entire thing back down. And so this limits the need to go recover your payload fairings from the ocean, to clean them and to reinstall them. And so while you sacrifice for some performance on your stage 1, carrying that much mass up, it all lends itself to that reusability. And so when you really start with a clean sheet and say, we need a launch vehicle that maximizes reusability and not necessarily this mass to orbit metric that's sort of based on dollars per kilogram and is a little bit more of an expendable type baseline metric, that's when you see these new markets open up because you've enabled true reusability as opposed to half in, half out.
Before we move on, just Brian, real quick. I know you guys have been working on Neutron. What's the timeline for it? Like, what's the latest on Neutron? I know everyone's looking forward to that.
Yeah, so we posted a number of hot fire engine videos lately, and if you haven't seen those, there's some great duration ones in there, nice blue flame coming out. So a lot of work going on at Stennis with our engine manufacturing. Some great posts online as well of what we call Launch Complex 3 in Virginia coming along. I already talked about water towers and concrete and all of that kind of infrastructure. And then the launch vehicle itself, we are still targeting a middle of next year demo flight. So something like the July timeframe. We'd said Q2 previously. We're still on track for that.
Thank you. Kurt, I'll kick it over to you. I mean, launch innovation is Northrop Grumman's game. Tell us what do we have to be excited about beyond LEO?
Well, I would say, we try to innovate where we need to, but we also try to bring in the tried and true. So in terms of avionics, software, a lot of our separation mechanisms and so on, we're going to rely on our heritage that we've been flying with for years. we are, the Firefly folks do have a number of really cool innovations. They're also using composite tanks for the first stage to get the mass fraction down low. They have these new engines I mentioned, the Mirandas, that use a tap-off cycle, LOX kerosene. That's the same propellants we've been using on the prior configurations of Antares. So it just makes it easier for us to slide into Pad 0A at Wallops and use the liquid fueling facility adjacent to it. We are going to incorporate reuse, and we want to propulsively land the first stage. So the layout of the 7 engines on the first stage, we have an outer ring of 6 and then 1 in the middle. And that will allow us to just reignite the one in the middle to get the thrust low enough to land that first stage, which is significantly lighter than at liftoff. So those are some of the architectural designs that we've thought long and hard about with Firefly, and we're planning to implement to enable the reuse of that first stage. And again, not only for the price point, but something I've realized from watching space so successful is their ability to accommodate a shorter lead time by not having to rebuild the first stage every time. So that's something I think that customers have come to expect and really like is a shorter lead time and more flexibility on the contracting side.
And just how many Antares 330 launches are you expecting in the near future here?
We're planning for 3 Antares 330s. Those will be cargo resupply missions. So we will be flying our Cygnus spacecraft, taking cargo to the space station, and then we would transition to the MLV, the medium launch vehicle, after that.
Excellent. Jeff, do you want to jump in here with what innovation in design features and launch vehicles are you seeing that really help us move the keep progress growing here as we head out into deeper space operations? I know you mentioned a few of them. I know the payload, not being limited to payloads, is a huge deal. I know you covered that, but what are some other things that you're seeing there in the market?
I think kind of focus back on the launch vehicle. We're excited to see the competition play out. So there's not like a single technology that we don't have a rooting interest. We're really rooting for a good, healthy market that it doesn't rely on NASA to support it by itself, but kind of relies on, commercial applications and that sort of thing, where NASA can be a user of these services. And maybe just to build on that for a moment, so with our commercial crew program, they're able to use flight history by launch vehicles for commercial missions as part of their understanding of the reliability of those vehicles and the flight performance of those vehicles. So I think as far as that sort of goes, we're just really looking to kind of continue to stimulate the market, and we're happy to feed back where we can in the development of these vehicles.
Go ahead, Rach.
Yeah. All right. I'm going to ask a question about international cooperation. And I see that we have some questions from the audience that I think will play into this also. And Jeff, I'll start with you on this one from NASA. How do you see international cooperation playing a role in the development and utilization of these advancements? And talk to us about the specific partnerships and collaborations internationally that NASA is pursuing.
Yeah, so the Moon to Mars architecture that I've mentioned a couple times is really a flexible framework, right? And so we're identifying the capabilities that we need, and those serve as opportunities for businesses, for those commercial partners and for international partners. So we've got the Artemis Accords, where we've got, I think, 46 countries now that are signed up to the Artemis Accords to have a common approach in space and kind of with U.S. leadership there. We're also building on the LEO partnerships that we've got with the lunar space economy. You asked for specific examples of international partnerships. So we've got the Canadarm3 on Gateway that's gonna fly on Gateway. JAXA is contributing with the pressurized rover. We've got United Arab Emirates with the airlock. So we're really kind of leaning into that International Space Station heritage. At this point in time, we've learned what it takes to have a good international agreement, international partnership. We actually have, like a training opportunity came out in our office a week ago about international project management. So it's something that we've become good at. We've got a lot of history with, and we continue to lean into as something that we're actively pursuing.
From the Rocket Lab perspective, we get to be like the poster child for aerospace international collaboration. It's fantastic. So, US-based company, huge center of gravity in New Zealand. We're launching from 2 different countries, and from those different sites, we've launched for national security missions. We've launched for NASA civil missions, doing storm tracking. We have great relationship with Japanese customers. So we've already talked about space sustainability. We had a launch previously with a company called Astroscale that's doing on-orbit debris mitigation. So that was a Japanese company launching with Rocket Lab from our New Zealand launch site. It's fantastic. And then, Rocket Lab actually has a footprint in more areas than that, across the US, but in Canada and Australia as well. So very happy to see the recent progress out of the State Department on ITAR and EAR revisions and what classifies as ITAR. I think that'll really stimulate more of that cooperation as opposed to limiting it. And I think we need more. It's always easy to say more, and I think they're taking a very methodical approach to it. But we pay a lot of attention to this because we draw on great workforces from across those regions, right? And so it's great to have that kind of collaboration.
Can you go into
I just chime in.
ITAR reform before we move on why that's important to Rocket Lab and kind of what more you'd like to see?
Yeah, well, if you go back a number of years, decades kind of thing, there's just very much everything that's created in the US that's related to propulsion technologies or guidance technologies is classified as a missile technology and therefore is restricted under ITAR. That's all well and good. And we've seen progress over the years, including Russian RD-180 engines powering Atlas Vs. All of these were steps in a direction of international collaboration. And now we're to the now we're to the point where they are limiting the ability for companies like Rocket Labs and others to engage with our international allies on development programs. You saw AUKUS come out, right? And there's pillars in there about space launch and hypersonics and a whole bunch of other things. And so I think what we're seeing is this wave of it's more important to be able to collaborate with our partners and allies than it is to try to protect these technologies to the nth degree. And that's a good thing. So because of that reform, I think we see the dividends on the civil, the interplanetary, the commercial side as well, where it allows technology to grow quicker.
Kurt, what's your perspective here? Northrop Grumman's been involved in some very massive international partnerships on technologies. Where do you see the importance of an international cooperation in the future?
Yeah, I was just listening to our Q3 earnings call this morning, and our execs were talking about how our international business has grown significantly, but it's really defense focused, right? And I'd love to see that expand to the space economy. I think Brian makes some good points. I think, for example, the Technology Safeguards Agreement, which is sort of like a treaty between us and the UK, it just got put out, I think it was 2 years ago. Absolutely. Where can we collaborate more with our allies? Let's buddy up with those who are, we're already doing that on the defense side. And so, why can't we expand that to the space side? But there's already a fair amount of collaboration. For example, Cygnus, we get our pressurized cargo module for Cygnus spacecraft from Italy. Thales Alenia Space, they're kind of the tried and true provider of those kind of pressurized modules. They've done a lot of the ISS work. So there's already a fair amount. I just think it'd be great to expand that and break down some of these barriers to collaboration with our allies.
Excellent. Thank you so much, Kurt. We have a few audience questions here we're going to try to get to here at the end. As I said, and continue to ask those questions, because if we don't get to your question, we'll have Kurt or Brian or Jeff reach out to you offline to answer them if we don't get to them in time. So this one question from the audience brings us back to something we were talking about with the launch sites, about how they impact the economy. Somebody asked, why are all the launch sites on coastal sites? Is it possible to build them inland? And I know, Brian, you talked about why we wouldn't build them near a metropolitan area, obviously, but with noise and pollution and other issues there. But is it possible to build them inland? I'll start with you, Jeff. We'll go around and your thoughts on that.
Yeah, so it really comes down to reliability. So you've got to, they do safety calculations for launches, and so part of that is the probability of an accident of the vehicle, and where it would go, and the population in those areas. So when we talk about overflight from inland spaceports, it is possible, but you're going to have even more reliability than we currently have in those vehicles. And it's probably a good thing to mention that the FAA has commercially licensed spaceports, some of which are inland. So there are spaceports existing there. For example, Blue Origin has a site, McGregor, that is a suborbital site. So it's possible, but it depends heavily on what the surrounding area looks like and the reliability of that specific vehicle.
Yeah, there are some inland sites like White Sands, and as Jeff mentioned, but really to go to an orbit trajectory, you're going to have to overfly populated land, and so that's where in the United States, the FAA rules, you're just not going to you're not going to meet the safety requirements unless you're adjacent to an ocean. So it's your expectation of casualty has to be below 30 times 10 to the -6, I think is the requirement, and so a lot of analysis goes into that. Other countries don't necessarily share our rules, but if you look back on all these flights in the U.S. and nobody has gotten killed. There was the one unfortunate accident. There've been some accidents in testing, ground testing, and so on. For example, a Virgin Orbit with the nitrous oxide explosion out in Mojave. But you look at our flights of orbital vehicles, even when they go wrong and they have an anomaly and they crash, it's over the ocean. People are cleared out of the way. It's very safe, and that's a tribute to those rules, even though it causes that all of these launch sites are next to a coast.
Yeah, there's one other interesting aspect here that historically rockets have had to drop stages, particularly stage 1, as they fly out, and so you clear out this area because there is pretty much guaranteed something to be coming down. As we enter full reusability era, and boosters are landing in targeted places, I go back to that airline model. I mean, this is why you see airports that are allowed to fly over land. You can take off, nothing is falling, and you're landing somewhere else. So there's that reliability assessment. Certainly there's a lot of potential energy on board a rocket, and that's why the keep out zones are so big. But I think it's a dialogue we need to have. I'm not saying that tomorrow we need to be launching from the middle of the US, but there are people saying that if we want to get to this space economy, we need to have more than just coastal launch sites. So I think reusability is a really important part of that.
Excellent. Thank you, Brian. A couple of people asked this question. I'm going to ask it too, because it's actually one of our session topics at the upcoming satellite show. But really the question is, what is the strength of the space industry supply chain, like the logistics supply chain to get all this stuff to where we need it to go? I'll start with you, Jeff, because you have logistics experience. Like, what do we need to improve on getting the right materials, getting like the right technologies? What is the strength of that supply chain right now?
I think I would say the strength of the supply chain is probably launch right now. We've got a lot of different innovation in that kind of mission segment right now. Mm-hmm. We've talked about the new vehicles, MLV and Neutron, that are coming out. So it seems like that segment is doing really well. What I'll say from a deep space logistics standpoint, we have one provider for those resupply missions to Gateway, that is SpaceX with the Dragon XL vehicle. We would really like to see that deep space supply chain, like I mentioned earlier, where we have, competition there and innovation that results from that. So it feels to me like the launch segment is very healthy, and then we're excited to see, kind of that continue further into the next mission phase of transit to Gateway.
Kurt, from your perspective, where are there opportunities for, say, like technology partners or startups to maybe improve that supply chain?
Well, I think I think the supply chain will respond. I don't see any limitations. It's particularly if you're reusing the first stage and you're not having to rebuild the whole first stage. As I said, that really shortens up your lead time. prevents you from having to build the large part of the rocket over and over again. I think just like airlines can get what they need when they ramp up production, I think we'll find the same for rockets. I think U.S. industry is strong overall. We see a lot of great innovation, the advent of automated machining and manufacturing. There's the pandemic hit everyone hard. There was a lot of inflation. There was workforce issues across the board. But I think we're seeing recovery across the board. We're seeing airlines, aircraft manufacturing pick up as well. I think that those suppliers of valves, batteries, component type stuff, they're going to be able to come back into full operation. I think that's the area where you can see new entrants come on, is these components that we need to buy. They need to be super reliable, affordable, and be able to ramp up the production rate.
I think it's a very healthy supply base. I tend to agree with everybody. It's interesting, though, in the aerospace market, that with space flight, you get into some pretty novel needs. And by that, I mean exotic materials. So let's think about titanium and Inconels and niobiums that are used for very hot and oxygen-rich environments. Avionics that needs to be able to withstand radiation. These are not things that are really being used in the same capacity in other markets, right? Automotive has a lot of avionics, but they're not rad hard. It's just not a thing that they need to care about. So I would say that in our industry, we feel it a little bit more in terms of those very exquisite needs. But overall, I think it's a pretty healthy supply chain. And I'll give props to the Rocket Lab supply chain team, where we're very vertically integrated. And so we have a lot of things coming in, but we're also launching very frequently. We're growing as a company across different product lines. And that's a testament to the people who are sourcing everything.
Thanks, Brian. We have time for one more question. Before I do that, I just want to mention, I mentioned Satellite 2025. For everybody who's registered for this, we're offering a special code that you can use to get a discount registration for Satellite in DC. If you use the code FUTURE, all caps, and you go to www.satshow.com, SATSHOW.com, you can save $200 on a conference pass. And also our CyberSat summit happening next month. You can use that same code FUTURE, all caps, by going to CyberSat Summit, registering, and you can save $150 off that registration. And that code is good through November 7th, 2024. So go to those if you're interested in further discussion on that. Please visit our website, satshow.com or cybersatsummit.com, and register for those using the FUTURE code and save some money. To the person who is asking about how can we lower the environmental impact of launching, I'm actually going to do an entire webcast dedicated to that early next year. So stay tuned for that. I do think it's an important topic, but I want to make sure we give it the proper time and get the right experts in to talk about how we can lower those environmental impacts associated with launching. But it is a good question. I don't want you to think we're ignoring that. The last question I want to ask everybody is one question we get asked all the time on this, and I'll put it in this way. When people ask you, why are we investing all this money to go to the moon or to go to Mars? Why are we doing all of this? How do you personally respond? Whether it's friends or family, why are we investing all of this money? Why is space so important? I'll start with you, Brian, and we'll go around. Brian, what's your answer to that question?
We are explorers, and we ought to be working on hard problems. And I see a lot of great technology. The human race has always used technology to improve our lives, and that needs to be spreading in all directions. And you never know where those different areas are going to collaborate in the future. So, seemingly unrelated things come together in the future and have incredible breakthroughs. But from my personal perspective, it's all about exploring continually into the unknown. There was exploring across the oceans and continents. We need to carry that forward. And then I am a big believer that, we need to continue to be moving out to discover new things and give more places to live. I would love to see space habitats. I would love to see moon bases. I would love to see Mars stations. And it goes back to that, I'm a sci-fi geek and I want to see it. I want to be a part of it. So we're also going to have to, cryogenically freeze me so I can be a part of it in the future too.
Kurt, you're on Tatooine right now. Why do we go there?
That's right. I think Brian said it well, that, it's a quest for what's out there. Let's understand it. Let's figure it out. It's fascinating. The stuff that we see from Hubble, from James Webb, it's incredible to just think about the size of the universe. Try to even wrap our heads around what's out there and how many universes there are. And it's actually blows your mind. So it's great to think about. It gets us. I also think it helps us to get beyond our daily focus inward on our petty problems, our controversies and our divisions. If anybody ever saw Captain Kirk when he flew on the Blue Origin suborbital vehicle, his interview, William Shatner, as he came out of the capsule about the Earth, looking at the Earth from space and how it just changed his perspective. I think if we could all kind of get that bigger Earth-sized perspective, we would maybe stop, shooting at each other and doing other crazy things. Maybe we could get that perspective to get beyond that kind of stuff. I think you're on mute, Jeff. Sorry,
I was saying absolutely great answer, Kurt. Jeff, how do you answer that question for friends and family?
Yeah, it's some of both. I mean, to me, it is, like the explorer aspect of this resonates with me. It resonates with the little kid that I used to be, right? Like if I could tell myself back in first grade, you're going to work on a lunar space station someday. Like how exciting and cool is that? It's the same thing that when we go to career day, we talk about that. It's inspirational, right? So certainly that. And I really like Kurt's comment, really about the overview effect, right? If you do listen to astronauts talk about it, you've got that overview effect. I think sometimes when we talk about exploring, people need to remember also the money is spent here on Earth, right? And that improves, like we had the economic question earlier about the economic impact around spaceports. It improves life on Earth from doing this. There are technologies and innovations that come out of this, that benefit absolutely everybody. So I think there's as much as we're excited and inspired to go out and explore, realize in the process of doing that we are also making life on Earth better.
Absolutely. Thank you, Jeff Brink, Kurt Eberly, Brian Rogers. Thank you all so much for joining us. Rachel, thank you so much for helping me out and leading this discussion. And I also want to thank our sponsors for bringing this fantastic webcast to you. Kepler, bringing internet connectivity to space. Northrop Grumman, which we've talked about for the past hour, how inspirational and influential they've been on commercial space development. And Rocket Lab, which is doing incredible things end-to-end across the supply chain, space supply chain. So check out what those companies are doing, and we really thank them for their support in bringing this webcast to you. Once again, my name is Jeffrey Hill, Executive Editor via Satellite, Executive Chair of the Satellite Show. Thank you so much for joining us, and we'll see you all for the next one coming up soon. Thank you.